All right, welcome to the next episode. We are now into Chapter 3, Transformations. To introduce us, I think I'll just better let the experts introduce this for you.
Got a little surprise for you, son.
No, Dad! Oh, you gotta be kidding me.
Yeah, I am. You're not getting a Porsche.
Let me tell you something, son. A driver don't pick the cars. Cars pick the driver. It's a mystical bond between man and machine.
Crash my car!
What you're about to see is totally classified.
Dear God, what is this?
We're under attack!
We're facing war against a technological civilization far superior to our own. Our enemy can take any shape. They could be anywhere.
It's a robot, like a super advanced robot. It's probably Japanese.
No!
I'll drive, you shoot!
You have to get the car. Trust me. Bring it!
Oh man, that looks so good. I can't wait to see that. This is going to be a good chapter. All right, 3.1. We are looking at transformations, a specific type of transformation called a translation. Really, a translation is going to be your shifts. So let's see what happens here. Okay, so getting started here. Here is the graph of y equals x squared. Now we're going to see what happens if we throw a plus q on the end. So if we throw in, let's say, q being 3 here. So that means the equation is y equals x squared, plus 3. Let's punch that into the calculator and see what happens. So the first one we want to graph is y equals x squared. Good. Graph that. Yep, that's the right graph. Let's throw down a second one now. And I'm going to put in front of it and go in front of the y and make it a thick line. So we're going to do x squared plus 3. Let's graph that and see what happens. There's the original. Oh! And it moved it up 3 units. That makes sense because we've always been talking about that on the end as being our y-intercept. So we're up 3, 1, 2, 3, and it's exact same shape. So that took it up 3 units. If we go negative 3, so then we've got y equals x squared minus 3, again, being that it's the y-intercept, we should be able to anticipate what's going to happen. And if we graph that one, it would go down 3 as well, and it would be the exact same shape as the original. The tricky part comes now when we start talking down 3. Start talking about what happens if we have x minus h inside brackets. So for instance, y equals bracket x minus a negative 3 squared, which is really just saying y equals x plus 3 squared. So notice that negative 3 became a positive 3 in here. If we graph that one now, let's keep the original there. Let's change this to bracket x plus 3 bracket squared. Let's graph that. There's the original, and ooh, neat. Move to the left. Let's do 1, 2, 3. Went 3 to the left when h was negative 3. 3 left. And what happens if we put a 4 in there? That means we're dealing with y equals x minus, I'm using minus because that minus is already in that equation, x minus 4 squared. So then when we graph that one, hopefully you can see it's going to do the opposite thing that that one just did. It's going to go to the right this time, 1, 2, 3, 4. And you can prove that by graphing it. So 4 right. The goal of this is to be able to look at an equation and visualize exactly where it's going to be without using a graphing calculator. All right, lots of different graphs here. And that's all the way on page 162, 163. So we want to be able to just identify all the different graphs. So this first part here is saying all of these graphs right here are on, and we're looking for those graphs here, the equations inside that. So parts that we're really focusing on now is, well, when we have y equals the absolute value of x. Actually, I'm going to go back one thing here first. With this, I'm going to do one extra thing. That plus 3 went up 3. I'm actually going to rewrite it as take the 3 to the other side of the equation. Y minus 3. You'll see why I'm going to do that in a little while. But for right now, I just want to make sure I have this written down. Y minus 3 equals x squared. And the same thing, take that to the other side of the equation. Y plus 3 equals x squared. Just to give you a heads up on y a little bit, taking anything that's talking about vertical, up and down is vertical, I'm going to move that with the y, because the y is the vertical. That's what they've done here in this question. They're now saying y minus 1, y plus 1, y minus 3, y plus 3. And if you graph each one of these, you're going to actually have to take it to y equals to be able to graph. So punching those into your calculator, you'll be able to see the original graph is the one that goes through 0 and 0. That's your original absolute value graph, the red one there. And that's going to be your original one here. So that's going to be graph C. The next one here, this is going to say up 1. So that's going to be B. This one's going to say down 1. So that one is going to be D. This one is going to say up 3. Apologies, up 3. So that one is going to be A. And this one is actually saying down 3. And that one is going to be E. Punching into your calculator, being able to see that for yourself. I will show you as we go along that whole process. But doing it for yourself right now, you'll be able to prove that that is true. These ones, again, starting with your absolute value of x. That's the red one. That's right there going through 0 and 0. And we've got some going right, some going left. X plus 1. that is going to be left 1. So left 1, that makes it G. This is saying right 1. So that is going to be I. This says left 3 units, so that's going to be F. And this one says right 3 units. So this one is going to be J. Taking it to the next one again, going even crazier. We've got y minus 1. This is going to be up 1. And x plus 3 is left 3. Find your vertex, which originally was right here. We are going to go up 1 and left 3. Oh. I'm sorry there. It's up 1 is half. There we go. And left 3, 1, 2, 3, right to there. So that makes M that one. The next one is saying y plus 1. We just saw in the first, that's down 1. And x minus 2, this is going to go right 2. So find the one that goes down 1 and right 2. Oh, that's O. Then we've got up, down 3 and left 1. Down 3 and left 1. That puts us at N. And finally, y minus 2, that's up 2 and right 3. Go up 2 and right 3. That puts us at L. Now you did not have to be able to do that from here. Using your graphing calculator, visualizing, and seeing what it does, that's what you wanted to be able to do at this point. I will explain what I'm doing for each one of these steps. Okay, the graph of a function may be translated vertically or horizontally. That's what we were just talking about. For example, the graph of y equals the square root of x plus 2 is the image of square root of x, and that is translated 2 units up. I'm going to write it a different way again, because if this is talking about up, which is vertical, I'm going to move it over with the y. Y minus 2 equals the square root of x. The only reason that we have that on the right side, the plus 2 on the right side, is so that you can punch it into your graphing calculator. That's the only reason to have it in that form. Having it set this way is more powerful for you. So I'm going to keep taking it back to that for you. The graph of root x minus 1 is the square root of x going down 1. And like I just said, we can rewrite it in the better way, this being y minus 1 equals the square root of x. And I'll let our friend explain that to you again.
The graph of a function may be translated vertically or horizontally. Here is the graph of y equals root x. The graph of y equals root x plus 2 is the image of the graph of y equals root x after a vertical translation of 2 units up. This equation can also be written as y minus 2 equals root x. The graph of y equals root x minus 1 is the image of the graph of y equals root x after a vertical translation of 1 unit down. This equation can also be written as y plus 1 equals root x. Here is the graph of y equals x cubed. The graph of y equals x plus 2 cubed is the image of the graph of y equals x cubed after a horizontal translation of 2 units left. The graph of y equals x minus 3 cubed is the image of the graph of y equals x cubed after a horizontal translation of 3 units right.
I know, super interesting as always. And that's what they were just talking about here, is if we move it to the left, x plus 2 is in there. If we move it to the right, x minus 3 is in there. And it seems a little bit tricky right now as to what's going on, why is some plus, one some minus. Let's keep looking at it so you can see as we go through. So we'll take a look at this picture here. From the original, y equals f of x, when I do a horizontal translation like this, I'm replacing. I'm going to talk about all the way through this transformation chapter about what do we replace in the equation. In this equation, from y equals f of x, the only thing I actually changed was that the x became x minus h. So I replaced x with x minus h. That's the replacement I did into the equation. Every time, 100% of the time when we do this, what we're doing is we're saying, if I take that and plug it in, this is going to be a horizontal translation. And they give you the rules here. If h is greater than 0, right, or less than 0, left. Taking it down to the vertical translation now, starting again with your y equals f of x. The change that we're doing in this one, the f of x stays as the x. Okay. So we've got the f of x staying as the f of x. The x is still the x. The thing that I did change, though, is the y became y minus k. So that's my replacement here. And as soon as we do that, no matter what the equation is or what the graph is, if I replace that, it's always going to be a vertical translation. And again, going up or going down. So into your bit.ly site there, trying to see, if I said y equals f of x, going down 4 units, which one gives us the new equation? Vote on that one for yourself. All right, first example with it. Here's the graph of y equals g of x. Sketch the image graph after each translation. Write the equation of the image. State the domain and range. Let's start by stating the domain and range of the original now. So original domain. The original domain goes from -1 all the way to 6. So -1 less than or equal to x, less than or equal to 6. Your range on this one goes from the lowest of 2 up to the highest of 5. So range 2, y, and 5. So there's my original domain range. Now let's get into our translations. 100% of the time, don't care what the graph is that we're starting with, what the equation is I'm starting with. If I say translation 4 units left, I'm going to say x is replaced because this is a left translation. That means they're talking about horizontal. Right and left is talking horizontal. Up and down is talking vertical. So as soon as it says the word left, I know that that has to be horizontal. It's affecting the x's, not affecting the y's. So 100% of the time, if I have a horizontal translation 4 units left, the x is going to become x minus, plus 4. To the left, x plus 4. The reason we're doing the opposite of what it says there is because of the additive inverse. What's happening in the algebra when we're solving is that it is going to move in the opposite direction. And I will do an example in class, and I will show you the why this is true in class. But the x is 100% of the time going to the left, 4 units, x becomes x plus 4. Let's plug that into the equation. The original is y equals g of x. Wherever I see an x, put in x plus 4. Y equals g of x plus 4. Done. That's A. The domain and range now is going to be just take our domain and move everything 4 left. So let's take that and move it 4 to the left. So our domain at this point for this new one goes -1 is going to go 4 to the left. 1, 2, 3, 4. That's going to put us at 3. The 6 is going to go 3 to the left. 1, 2, 3, 4 to the left, 4. Which will take us to 10. The range now. We did nothing at all vertically. We did not move it up and down. I did not touch the y. So my range is not touched. It is still going to be the same range. Next one, B. If I'm doing 1 unit up, because up is vertical, this is a vertical translation, 1 unit up. As soon as it's a vertical translation, 100% of the time, if it's vertical, I'm changing the y. I'm not touching the x. I'm going to replace into the equation, wherever I see y, I'm going to replace it with y and 1 unit up. I'm going to do the opposite. Always the opposite because of algebra. Again, I will show you the example of why. It's going up 1 unit. So we're doing the opposite. Vertical is y. Translation means I'm going to be adding or subtracting. So y goes with, vertical. The y goes with vertical. The minus right there because I'm going up. So taking our equation, we started with y equals g of x. Anywhere you see a y, put a y minus 1. Y minus 1 equals g of x. And now, so that you could use your graphing calculator, you could punch it in as y equals, take the -1 to the other side, g of x plus 1. Either of those two is an acceptable answer to leave it as. On your diploma exam, you'll have either one of those two. You've got to be able to recognize both forms of this. So we can take a graph and we can put horizontal and vertical parts. Oh, I forgot to do your domain this way. Nice, so sorry, domain and range with this one. Your domain this time, we didn't touch the x, so it's going to stay the same as the original. Your range this time is going to go up 1 unit. So I'm going to add 1 unit to each one of these. The 2 went up to a 3. The 5 goes up to a 6. And there's your domain range. So you could have both a horizontal and a vertical translation at the same time. When we put it into the graph, you'll be able to see y minus 4 and x minus 2, which is telling us right now that we are going up 4 units, and we are going right 2 units, which puts that vertex up 4 right 2. So this is the form that I'm always going to be referring back to. Y minus k equals f of at x minus 8. Hey, combining those two together, let's see if you can figure out this one. Vote for that now. All right, so let's look at the next one. J of x. 4 left, 5 down. So 4 left. First thing you want to decide, this is a translation. Is it going vertical or horizontal? And left is on the horizontal axis. So this is horizontal. Identify that. Now we say the x is going to change. X because it's horizontal. And then we do put it's either plus or minus because it's a translation. X because horizontal. We're adding or subtracting because of the translation. And we're going 4. So now we have to decide 4 units to the left, opposite sign. That's into the negatives. Because of algebra, we're going to have the opposite additive inverse plus 4 into the equation. 5 down. Down is vertical. So as soon as we have vertical, it's a y because it's vertical. It's going to be plus or minus because it's a translation. And we're going 5. And because it says down, we're going to be using the opposite sign. Plus 5. Let's punch that into the formula. Y equals j of x. The first step says 4 to the left. That means x went to x plus 4. Wherever you see an x, put x plus 4. Y equals j of x plus 4. Step number 2, it says we're going 5 down. The replacement is wherever you see a y, put a y plus 5. Y plus 5 equals j of x plus 4. It is perfectly fine to stop and leave the equation there. But we could take it and say y equals j of x plus 4 minus 5. And you could leave it like that as well. Let's graph it now. Take every single point. I'll use these points. And move those points 4 to the left. 1, 2, 3, 4, and 5 down. 1, 2, 3, 4, 5. We're going to put it right there. Let's take the next point. 4 to the left. 1, 2, 3, 4, and 5 down. 1, 2, 3, 4, 5. Right there. Take the next one. 4 to the left. 1, 2, 3, 4, and 5 down. 1, 2, 3, 4, 5. Actually, this one should be over a little bit. Sorry. And then now, we're going to have the exact same shape. So if you have other points, you could take other points if you want. For instance, you could take the y-intercept, move it 4 to the left, and 5 down. So then we'd have that point to go through as well. And same exact shape that we had. Now we've got a rational graph. The beauty of this method for transformations is it does not matter what graph we start with at all. You follow these rules and it works for 100% of the graphs. Oh, 3 units left. Decide for yourself, is that horizontal or vertical? Left is horizontal. 2 units up. Up is vertical. Horizontal deals with the x. vertical deals with the y. So let's start with the horizontal. The first one says, wherever you see an x, let's replace it with x3, and it's plus or minus in the middle because it's a translation. X, because it's horizontal, affects the horizontal. The plus or minus in between here because it's a translation. And if it's going left, we do the opposite. Left to the negatives, we do the additive inverse, plus 3. Vertical. Vertical is y. So y. Then we're going to have a plus or minus because it's a translation, and it's 2 units, and it's going up. So we're going to do, that's into the positives. We're going to do the opposite, which is to the negatives. And all we do is, wherever you see an x, put an x plus 3. Wherever you see a y, put a y minus 2. So y equals 1 over x is our first thing. Into the x, we put x plus 3. Into the y, we put y minus 2. That is perfectly fine to leave your equation like that. Some people like to take the 2 over to the other side. So y equals 1 over x plus 3 plus 2 is fine as well. Done. That's it. Okay, getting a big trick here now. Getting deeper into this concept. Y equals 1 over x squared. That's shown here. We're going to translate based on what they say for those two, for A and B. But we're also looking for the asymptotes. So let's identify the original asymptotes. So original asymptotes. Originally, the asymptotes are going to be, we've got vertical, we've got a horizontal. So x equals 0 and y equals 0. There's our two asymptotes. Now let's go to part A. Part A says y minus 3 equals 1 over x squared. What you want to do is compare to the original. Look at where the x is. Think of the x as having brackets. Think of the y as having brackets. And you have to ask yourself, did I take anything and change it in with those brackets where the x is, or in the brackets where the y is? And in this case, we have x squared, we have x squared. I didn't do anything different to the x squared. So there's nothing that's going to be affecting the x. So x not affected means no horizontal translation. But if I look at the y became y minus 3. "100% of the time, as soon as it says y becomes y minus 3, that's a vertical because it's y. Translation because it's adding or subtracting 3 units. And now you have to decide which direction. It says minus 3. We're going to go in the opposite. As soon as we do these replacements, the opposite, we're going to go into the positives up. So there's part A. Vertical translation, 3 units up. So now you have to say, okay, if it's vertical, it doesn't affect the horizontal translation. It will not affect anything that's really on that horizontal, but we're going to be moving everything up 3 units. So if I use this vertical asymptote, and if I move that asymptote up 3, it's still going to be at the same spot. I'm just moving it straight up along itself. But this horizontal asymptote, if I move it up 3, because I'm moving everything up 3, that asymptote is going to change. So the first one, x equals 0 is going to stay as x equals 0. Y equals 0 goes up 3, 1, 2, 3. So we got a new one at y equals 3 for an asymptote now. Ooh, part B now. Ay, ay, ay. This is crazy stuff. Part B says y plus 4, x plus 3. Into the x spot, I put x plus 3. Into the y spot, I put y plus 4. So x is replaced with x plus 3 in the equation. Y is replaced with y plus 4. The x. This is going to be a horizontal because it's x. Translation, because I've got adding or subtracting. 3 units, obviously because it's 3. And now you have to decide the direction. This is the hardest part. Always the additive inverse. I have plus 3 there. It's going to go into the negatives. Negatives on the horizontal is left. Now for the y. Y gives me vertical. Vertical because it's a y replacement. Translation, because it's adding or subtracting. 4 units because it's 4. Additive inverse. It says plus 4. I'm going to go to the negatives down. Last point here. Don't get tricked up if they do something like this. If they would have said y equals 1 over x plus 3 squared minus 4. The horizontal is inside the brackets with the x. Anything that's inside the brackets with the x, horizontal. Anything that's outside the brackets of the x is vertical. I'm going to have you take everything to the 2 sides of the equation. Y minus k equals f x minus h. This is what you saw on the other page there. 2 sides of every equation. Split it at the equal sign. This is the side with the y. This is the vertical side of the equation. This is the side with the x. This is the horizontal side of the equation. Anything that's inside the brackets with the x, keep it on that side. Or if it was originally there. So for instance, that 1 was originally there. That 1 stays there. But the negative 4, I'm going to take to the other side of the equation, to the vertical correct side. I will go through these again, and I'll get down to the y in class, because it is a little bit tricky all the way through. Being able to take this information now and explaining it to yourself, do your 3 questions there, and we will discuss all this and look at some more examples in class.